In this video, we'll be creating all the mounts for the front blade of the bulldozer. Starting off with the big arms at the side of the bulldozer, which form the main mounts. I'm just starting off with a box here, and another part I'll be needing to connect these boxes to the big axle is a cylinder. You can see me creating that here, trying to align it nicely to the center of that axle. Because that axle doesn't have its own pivot, I'm going to have to align it manually. Here we are. Now with that done, I need to align them slightly more. This looks about right. Then I'm going to turn the segments down to make it easier to work with. And I think I'm going to use 18, which is always a nice number to work with. And then I'll perform an inset on it. This inset just serves to create the hole in the center there. With that hole done, I'm going to go for the next adjustment, which is creating a division in the center. The reason for this division is the connection for the mounts to the big axle is some sort of clamp. There are two halves of a cylinder that are clamped around this part. They're connected with big bolts, and if you'd loosen those bolts, you'd be able to remove the mounts from the center axle. So that's what I'm doing here. It's a little bit tricky to model, but not all that difficult. These parts are actually sort of extrusions, and these extrusions, they are where the bolts for fastening this clamp mounted to. So first I'm aligning it on one axis, and then I'm using the snap to move them to a perfect perpendicular shape. Doing the same on every side. Not very difficult. There we go. That done, I'm going to add a few subdivisions to make sure these things are hardened up nicely, and then adding an extra one here. I'm going to add an extra subdivision in the center, move that out slightly, and then I'm just simply going to move these in. This is an interesting shape. I like how this has this sort of beveled look, so I'm definitely paying attention to modeling this correctly. If that's done, I'm selecting these shapes. I'm using select by angle. Makes things a lot easier to select. I'm just simply removing these loops again, as I'm going to use the inset trick to add some extra loops here. The inset trick is easier to have loops running around corners, because then you have to manually connect them. But if I use this trick, as you can see at the corners of those extruded parts, it just looks nicely like it should. Here we are. I'm just going to add another line here and two extra connects here, and there we are. Two more in the center. And now we need to model the part at the back of these clamps, and this part just connects to the main mounts for the front blade. Nothing too difficult. I'm just using a line tool, moving this around. As I said, these things are mounted together with bolts, so I'm just using the same old bolt model as I have all along, and I'm copying it down and reusing it. Then I'm just mirroring them, so they sit on two sides. With that done, I can just attach all of them. That's a lot easier to work with and reduces the number of objects in my scene. That done, I'm going to add a few extra edges here. Might seem a bit strange since I'm creating n-gons, but of course, I'm simply going to fix this up by removing one loop there. If I'd have created this before I did the inset, then I wouldn't have had this problem, but fixing this manually afterwards isn't that much trouble at all, so I'm just doing it this way. So there we are. Added turbo smooth, looks pretty good. Just need to do a slight adjustment to this axle in the center. So I've selected that object and I'm working on that one. Selecting every two other edges of that cylinder. And the reason for that is there are actually 4 holes for another set of nuts and bolts in the center of this axle. I presume that's just for fastening things together. Don't have that much insight into how this bulldozer is exactly constructed. So there we are. The shapes that we need. And look at that. That looks pretty interesting, I think. Alright, with the entire connection done there, we can just focus on this big metal beam here. And this beam will form the main connection between the body of the bulldozer and the blade at the front. I'm simply adding in a few large subdivisions and a few smaller ones at the edges to get the main shape down. And I've added this interesting diagonal one at the side. That's because there's actually an extruded diagonal shape on this beam at the side. It's not that big, but it's interesting enough to model. Make sure these line out nicely. And the side of this thing is also slightly beveled. So I'm just moving these edges around a little bit. It gets a little bit tricky with that extruded part over there, but nothing impossible. So I'm chamfering this one up and then moving them around to add some extra subdivisions. This is all just prep work for details that will be modeled into the beam. See, there are a lot of subtle height differences in what might seem like a simple shape. There's another slight extrusion here. Of course, if I do this sort of extrusion, I need to make sure there's a lot of geometry to support these edges. Okay. Have a look at what that looks like with turbo smooth. And there's a slight problem there at the top. I haven't taken into account the exact smoothing there. There we go. Move it in with edge constraint, move it out so it gets aligned with the edges next to it. Okay, so now I'm moving the pivot. And why am I moving the pivot? Well, since these beams don't sit exactly parallel to the body, I had to move them out slightly. You can see me rotating them slightly so they line up with the mounting points on the blade, or well, the soon-to-be mounting points on the blade. Here, a small little detail, nothing too complex, just a box. Adding some edges to it, doing a little bit of modeling. Nothing too crazy. I'm using the scale tool here instead of the move tool because I think it's easier for doing symmetrical, uniform movements. Probably have seen me do this before. Instead of moving up and down, I just use the scale tool. Okay, so we have our shape down. This is the shape itself here. Starts to get a little bit more interesting. There's this sort of T shape coming out of it and actually slopes down at the end. It has a few more slopes to it. So I'm adding a few subdivisions. Make sure this works. Extruding that edge just to make it a little bit more interesting. And then there is well, this is interesting. There's a sort of handle attached to this shape. This thing, I think it's a sort of step for the driver or the soldiers that will be going into the cabin of the bulldozer to step on and to finally climb to the top. Because the cabin sits almost 2 meters high above the ground, so there definitely need to be some contact points for humans to be able to climb on top. And this thing actually has sort of ribbed structure to it, expect as to not slip, and it gets a little bit more grip on it. And that's what I'm modeling here, nothing too difficult. Got a small detail here, as you can see that was messing up the turbo smooth. Looks better. And then I'm using symmetry to copy that one over there. I'm making that one red in the center. And the red color, as I said before, it's where humans are supposed to touch and have contact with the bulldozer. So that's what the point of the whole thing is. And here's another part that gets added on the top. This is a sort of metal plate with a few details added onto it. Creating the base first, and then moving out these parts using Swift Loop to add another subdivision. I'm going to extrude on it. And this is what the shape looks like. It's sort of slope part. Quite interesting. You'll see right away it has a bit more detail on this. I'm just creating the bare minimum here. Using Swift Loop to add the necessary loops. We are extruding the bottom. Why am I extruding the bottom? Well, I want to do that little inset trick again, and I don't want the bottom to get inset, so I'm extruding a temporary set of polygons to sort of catch the unwanted inset effect. That one out there. and performing a ring here. And the reason I'm performing a connect here is there are lots of slots in this thing. Every alternating one, there's a slight extrusion. So I'm using the dot loop here, which is interesting. And just need to deselect a few parts. And with the dot loop, I select every other polygon. And once I have that, I can simply use this for an extrusion. So if I would have to select these manually, it would take like up to a minute, 2 minutes, while with dot loop, you can just do it in one click, and then if you deselect, just deselect the unwanted ones. There we go. There we have the little pattern I was talking about. I need to add another few extra edges to make sure that looks correct. And there we are. I added a slight detail to this side, which was not difficult to model at all. Then I'm adding a few edges here. And the point of this part with the extra extrude is this is what will actually be connecting to the mounts on the front blade. As you can see, it gets a little bit smaller, slims down, slopes down. And then there's an extrusion which will eventually end in a part with a hole in it. And this part with a hole, as you can see me creating here, I'll be creating the hole in a minute. Part with a hole is where a big axle will connect to the front blade and its mounting points. Now I just need to weld these parts up. As you can see, I'm doing a weld with edges, and it's basically like a weld with two verts at the same time. It's just a little bit less, how would I say that, reliable. It can react strange in certain situations, so only use it when I want to weld fast and it's an easy situation. Right, so here's the next detail part. This one's really easy. It's just a plate which I think provides some protection for some part of the bulldozer. It's really nothing too difficult. Also, as you can see, I'm modeling this part straight compared to the blueprints where it's slightly angled. The reason for that is it's much easier to work with because you'll have to mess around with your coordinate systems a lot more. I just prefer to avoid doing that. Then when I'm finally done with the part, I rotate it into the correct position. You've seen me do this before a few times. It's nothing too shocking. It just makes working easier with complex parts like this. Okay, so the next part up is you can see me creating a cylinder for that. There's this pretty big piston that sits on one of the beams that connects the blade to the body. And this piston is quite interesting. It's really massive, really chunky, and it has this interesting hexagonal rounded shape at the front. So I'm starting off with this hexagonal shape, but the problem is it goes from a hexagonal shape to a round shape, and it's a little bit hard to fix that. But I'm just going to select this and then use a little trick. There's a loop tool, and if you hit the curvature button and then circle, you can get this into a perfect circle. So nothing messed up about that. As you can see, I went from a chamfered hexagonal shape to a perfect circle using a few button clicks. So loops, loop tools, and there's just two buttons you have to press there, which would be curvature curve and then the circle button. And as you can see, I added a few more. I'm just going to click the space button to space them out and then hit the circle button to get them straight. Get them into a circle shape, sorry. I'm adding a few extra edges here to make sure that these corners are rounded nicely. And then I'm selecting all these corner polygons, forming an inset on them. I'm just going to do the same circle trick here. The thing is that the circle trick only really works correctly on selections of borders. You can't really do it on polygon selections. As you can see, this is really allowing me to work quickly with this part. Otherwise, this would take so much work, while a few interesting uses of the graphite modeling tools can really speed things up. So I'm chamfering this part here, and why am I doing that? Well, that's simply because there's some extruded and beveled parts there. Just going to select these edges, do a ring select around, convert them to a polygon selection, and then just do an extrude and an inset get those down right. Use Swift Loop tool, set boundaries on them. There we are. Now we can just continue on the back of that part, the rounded cylinder that I was talking about. First, there's a slight bevel, which I can tell by looking at the reference. And then there's the extrude for the actual cylinder itself. With that basic setup done, I'm just going to concentrate on finishing up these holes first, which is just a few extrudes and insets, or you could just alternatively use the bevel tool with alternating options. I'm not minding the front there, that looks obviously messed up. Just looking at the smoothing of what I've done before. Needed a few edges, did that. And back to the main cylinder. And this is just really the rough modeling, trying to get the shape down. Proportions need to be right. Because this is such an important part, I really want to get the proportions right and not start detailing too quickly or have the general proportions down. So I think these are okay, and then I just start adding a few more edges. Another chamfer here for this sort of ridge that runs around this piston. And there's a bit more detail here as well. Some sort of ridge thing. All right. A few more insets, a few more chamfers. Basic shape is looking okay. I'm going to go back to the front and just add a little bit more detail there. There are no holes there, since the bolts are at the back of this part. I'm going to cap it up and start modeling the details on the front. Once again, you have this hexagonal shape here. And this one's a little bit tricky also. You get this sort of, what I call this, a star-shaped part that extrudes. And it's a pretty complex shape. As you can see, the cylinder, this piston thing, it's pretty cool on how it all fits together, but definitely a challenge. So I'm using the right selection of polygons here to get things right. You can see there's another problem here, mostly due to wrongly scaled edges. And I'm just using the scale tool to get these right again. As you can see, some of them are inverted, so I figured it's going to be a little bit too hard to fix this. So once again, using the loop tools, there we are. So you got to remember when you use the loop tools to get a perfect circle in there, sometimes you gotta just use the make planar tool, because it pulls the verts out of their plane sometimes. Okay, so right now I'm using the array tool to get some bolts in there. Nothing too complex, just using the pivot of the big piston. Got the bolts in there, attaching them together. You've seen me do this a million times already. Then back to the back. I prefer to alternate this a little bit, so I build this thing up in two directions. Just go to the back, go to the front. Man, it keeps things interesting. Although I think the front is almost done now. We just need to add a separate sliding piston axle in there. So why I'm adding these straight lines here? Well, it's the back of this piston, and there's actually a straight part that extrudes from them. Actually pretty complex. Once again, this round part, it changes into a straight part. And well, quite tricky. I'm actually going to have to model most of this by hand, because there's no button to create instant straight parts. There's a few buttons to create instant round parts, but this I will have to do manually. So as you can see, I did that on the other side as well, and then I'm extruding these parts. I need to fix up a lot of puzzles here in terms of n-gons and how things connect. You can just see me move the verts around there. Now I'm using an inset here. Why am I using an inset? Well, there is a round opening in the center for an axle to fit through. There we are. Using the round button again and slightly rotating. Get a circle. You can see things are really cramped here. This is definitely a difficult part. I'm just going to scale these down a little bit so that looks slightly nicer. I've scaled them outwards a little bit because on the reference they actually bulge outwards slightly. And then I'm using a few inset and extrudes to move them inwards. I need to fix up this end, which is basically just a few extrudes to get things down right here. And it turns out that the number of segments on one side doesn't match up to the other side, so I have to fix that by, I don't know, removing a few. On the inside, it's a closed loop. It doesn't run along the entire object, so I can just delete a few. Yeah. This loop is actually not needed. Makes things complicated for me, so I am removing it. There we are. You can see having less loops makes it easier here for me actually, so that's what I want to do. Again, doing an extrude. Moving these down to match that edge down there. And then just simply selecting these and welding them together. And another shift move down. Align them on the Y-axis. Move them over there. And now I can simply just use the bridge tool between two separate edges. Bridge. Need to make sure that all edges, all verts are welded, so I select them and hit weld. And then back to the front. That's what I was talking about. A piston is always made out of two parts. There's the sliding part and the part that actually holds the pressure and pushes the sliding part in and out. So this purple rod here at the moment is the rod that moves in and out of the piston. You know, that's the polished part of the piston. It's so polished because it always keeps moving up and down. And the brownish part I'm working on here is really simple. This is just another round part which will be used to attach this to the front mount. An axle will go through, and that's pretty much all there is to it. Attaching them together. Move this over there, and I want to do things cleanly. I want to connect these together. I made sure there was a subdivision in the center of that round part so I can connect it to the rod. And then I need to move the verts out so they sit almost exactly flush with the surface. Some of them I can use snap, some I can't. And when that's done, I'm just target welding these parts together. Connect it up. Now I just need to add a few extra edges to make sure that things are rounded nicely there. That part is actually slightly thicker, so that requires some geometry. And of course, because an axle will fit through there, I need to do a few insets. And there we have it, our very complicated piston part. Just going to move it into the right position. And it also shows me that I have to change a few parts around slightly. Rotate it over the correct pivot point. As you can see, I move the pivot point. That makes sense. And then rotate this to match the blueprint. With that part done, we move over to the next big important part of the mounts for the blade. And this one are two very large pistons that attach to the hood of the bulldozer, and they move the front blade up and down. But before we can actually get to those, you see that I'm modifying a few parts of the bulldozer hood where they will actually attach together. There's this difficult part that we modeled before of the angled cylinders that actually are connected to the hood of the bulldozer. And on the side, there's this strangely shaped part which I've just modeled. And right now I'm just working a little bit on the rounding of these parts. This is just tweaking work, but I want these to be correct before I even consider moving on with modeling the rest of this part. So I add an extra few edges here, so I need to make sure that I move these around so that the roundings of this part are correct. I'm also connecting these edges up just to make sure that everything is correct. Alright, Now that I'm satisfied with that part, and as you can see, I added a few bolts to the side there. It's nothing too hard. You can do that very quickly. I'm going to start modeling these big pistons that sit, actually, they're vertical instead of horizontal like the other ones because they move the front blade up and down. Simply starting with a box and adding a few extra edges to start defining the shape. And then I want to do a connect to make sure that these are hardened up nicely. Chamfer here. Why? Because I want this sharp little division in the center, and then 2 swift loops at both ends to make sure that those parts are correct. Then an extrude here. And this part is actually only the mounting part. This part is connected to that cylinder we just worked on, and this part will hold the actual pistons. It's not very complex. You'll see right away how it works. We have these parts selected here. Doing another extrude on them. Move these in slightly. And then add a symmetry on top here. I need to move them around slightly so they're actually centered compared to that cylinder. And with that done, I'm pasting the turbo smooth on there. I'm just having a look at what this looks like. That looks okay. So right now I'm creating the cylinder to start my main piston out of. Rotate that downward. Set the number of segments correctly. And then using the move and rotate tool to get its initial orientation in the correct position. I use the type in there just to get things neatly into a correct number. Moving that one all the way up to the top, extruding to the bottom, and then adding a few segments so that I can start modeling. I'm also moving this into the correct position, and I can see that I need to adjust things slightly there. Not exactly fitting yet. And for that, I'm just going to use the scale tool to scale it slightly smaller so it fits between those 2 clamps for the attachment. Then I'm using an extrude on this part, and also using a few swift loops to define my geometry there. Swift loop at the top. The reason for that is so that I can perform another extrude. This is a cylinder, so working on this is very easy, as we've noticed before. At the bottom here, you can see there's a sort of end part that gets slightly thicker and then has a small bevel to make it thinner and actually meet the sliding rod on the inside of the piston. Extruding using a bevel here, and then throwing an inset using the bevel tool. Add a few extra loops. And that looks about okay. I need to add a loop in the center because there's a little inset ridge there for 2 parts that are, I don't know, screwed together or something. That one there. And I'm performing a slight extrude. And I've actually detached that plane to a separate object so I can just start the rod, the sliding rod on the inside using that separate part. And the advantage of that is your pivot will be in the right position, your number of segments will be correct, and the part will be orientated in the correct way. We have the main setup for our piston done. So what I'm doing right now is adding some more details to it. As you can see, the civilian piston is quite simple. It's not too complex. The military version is has this part heavily armored. Why is that? Well, it sits at the front of the bulldozer. It's very open, and if this would get hit by an RPG or something, it would destroy a critical system of the bulldozer. So it definitely needs to be protected adequately. So the military version has this sort of, I guess it's something to attach ropes to or something to hold on to. This sort of a loop thing. And that looks slightly too rounded. So I'm adding a few more segments to that. Here we go, using a ring connect. Okay, that's about good. Now I've created a plane here, and the reason for this plane is, well, this is going to serve as the base for all the armor that I will be adding to these pistons. And it's interesting, this armor actually, it's really big and fat. It sits around the outside of the clamps that hold this piston in. Adding a few subdivisions, and that way I can move this into the right position. The armor is rounded at the back corner. It goes up quite high, sloped over there. And I'm going to model this symmetrical. The armor is symmetrical on both sides of the piston. Here we are. Now, interestingly, there is a sort of slope part that cuts off that corner there. And it's a little bit tricky to create something like that. I need to add a few extra edges for that. With that done, I can just weld these together, and then I will use snapping to snap these into the correct position. Now you can say you've got a triangle there. That's not going to work with Turbo Smooth. That's right. We'll get back to that right away. First, I'm going to model the other side, and this side is different. It's a little bit simpler. So once this one is done, we'll copy it to the other side like we've done with every part so far. Okay, there's a little slot for the loop thing that comes out. And now I'm actually creating an opening for the armor to fit around the hood of the bulldozer. Moving this around slightly. It's an interesting shape. It's got a few weird little twists in there. So I just need to go ahead and add those. The basic shape is almost there now. Now it's down to getting the flow right and connecting things up nicely. So we've got these things done here. And I'm going to fix up this little area here. What I'm doing here is I'm actually going to leave it as a triangle there for now. I can fix it up by adding one in the center, but it's not going to mess things up. It looks okay, so... Right, there's not that much more to do here on this thing other than add some loops to harden the edges out. And there's really a lot, since this part isn't all that simple in terms of shape. And after that, I've added a shell on top and just added an extra loop around that shell to get things done nicely. Because, well, actually, armor has a thickness. You can't just use a simple plane for that. Once that shell is done, I'm just using a few extrudes to get that part on the top here extruded nicely. There's also a few details on the side there. They're really not complex, and I don't think it's worth showing you guys that I modeled these separately. They're just cylinders with a few insets and extrudes on them. At the back, there's also a little plate with some bolts added, and then there's this part at the top, which I will once again create a hole in there. And the reason for this hole is it'll attach to, it'll be used as an attachment point for the lights that sit at the top of the bulldozer. And you can see me using the make planer here. Slight problem here with that rounding tool. We are connecting those together, then using a connect. And once again, connect here. Use scale to upscale it so it stays uniformly rounded. And that looks about right. Okay, so the lights are on top of the bulldozer now. Those are pretty simple to model. They're just a box and some splines. I also copied a part from the light at the track covers, so that's not really that difficult. You can figure that out yourself by looking at the model or looking at reference pictures of this bulldozer. Copying it to the other side, and as you can see, there are also some attachment points modeled at the back of the bulldozer there. These were also done separately. They're nothing too difficult, just some extruded parts with a cylinder in between there. You could model these separately. I've decided to model them in one part, which made it a little bit trickier. You can see it's a big mess of wires there, but it's nothing too complex. If you can follow this one over here where I'm creating the attachment point for this piston, then you can definitely create the other ones as well. Right now, I'm just adding a few more small details at the back and changing this silhouette a little bit. This part isn't very visible, so we don't need to pay that much attention to it. That done, I'm just going to add a few more extra loops here to make sure that it's rounded off nicely. Also at the back. With that done, that looks almost okay. Just some ugly smoothing at the top. We can fix that with 2 extra edges. And there we are. That looks almost okay. Still another one I forgot. As you can see, there's really not much to this. Very simple. Because I kept this as a separate part, I can have the wires run through all the time. And now here's that little piece of axle I was talking about. You can just simply use a cylinder for that. Always remember to reduce the number of segments to a workable number. And with that in place, I'm just going to simply add some more geometry that I can use to make it look like it's connected to that big rod that comes out of the piston. Something like this. You can make planar, be easy. And there we are. Add those extras. Now I just want to attach this part together. There we are. Don't need to add too much detail to that or anything. I mean, it's not really necessary. You'll barely see it. That part will be in the shade most of the time. And that's something I do want to add on the outsides of this mount for the piston. There needs to be some sort of visual clue if there's an axle running through it. If you can only see it on the center, it's not going to be that interesting. So I'm going to create one of these, copy it to the other side, rotate 180 degrees, and move it back in. And that's it. And then just attach it back to this part. Of course, can't forget, need to make them a little bit larger, like that, so that they're really visible. Oh, that's interesting enough. Okay, so we've got this part here at the top. This one's a little bit too wide, so I need to move this in. We're just doing the same thing here, leaving a visual clue on the outside that there's an axle running through there. Makes it interesting to look at. And I'm just going to grab this same part and use it at the bottom. On the reference, this might not all look 100% the same, but it doesn't matter. It's just faster to work this way, especially on a part that's less visible than others. That's done. I'm going to grab this part from the big beam. I'm going to reuse it as well because there's one funky part that's on this bulldozer and I couldn't find much reference on it. It was a little bit tricky. And it's this sort of rod that connects the back of the front blade with one side of the frame. And they're calling this connection a tag link. And the tag link sort of uses the same connection with these two halves that clamp together as the side there. So I'm just using this part. And the tag link connects to the left front side of the frame. And it goes to the right rear side of the front blade. So basically that's what I'm creating here. And it's not that hard. I mean, just closing this part up. Can't forget to do a few connects. Using the connect tool to add the proper amount of segments here. Connect these up. And connect those as well. Okay, now we can just use that big cylinder in the center, which will be the main connecting part. It's slightly slanted like that, so I'm just going to do the same thing. Then copy this part over there. Connect them up together. Form an inset so it smooths correctly. And then I'm just going to add a little detail on the top using a box. I felt like because there's really not much reference on this. I'm mentioning this. I could find almost no pictures of this. So I'm just making this up. I felt like that single cylinder is just a little bit too bare. So I'm adding a little bit more interesting details to it by using this box, dividing it a few times so that it subdivides nicely. Make it a little bit smaller for a second copy. I'll make it a little bit lower and move it to the front there. And with that done, creating another small detail. As you can see, this is just simple work, some primitives that I need to combine together to fake the details. This is some sort of cover under which a few hydraulic hoses are mounted, and you'll see some hoses spring up from under that cover. All right. Okay. Take those down, and I'm just going to do the same thing on this side. Got a lot of separate parts here. We'll be attaching those together in a moment. Just making sure the profile is interesting enough. Making sure to add all the correct edges there. Stitch those together. Or a shell on them, just to give it some thickness so that you don't get these single plane see-through type of parts that we really don't need. Right, so one extra part here is this little cylinder. And once again, I'm making this up as I go. There is no reference for this. I'm just adding parts which I think will look interesting on this object. And this sort of stuff, I mean, I've done this all over the bulldozer. Create a cylinder, do a few insets and extrudes, and you can always create a quick, easy shape that adds some interesting detail. Alright, so that seems about done. I'm attaching it. And now I'm rotating this to get it into sort of the correct position. What's missing here is some place to mount it to the front blade. So I'm creating some sort of box over there to be able to connect things. And I don't really know why they exactly added this sort of connecting rod between things. I presume it's just to limit movement and make sure that the front blade can't bend in the wrong way. But what it does is it nicely fills up a bit of empty area between the front of the bulldozer and the front blade. Fills up that place nicely, so don't mind adding it. Here we are. Okay, this part looks okay by itself, but that blue box is terribly uninteresting, so we're just going to add a few chamfers to it, a few extra edges. There we are. Change the general shape a little bit. And then just copy the Turbo Smooth and paste it on. Okay, so what we're going to do here is make it a little bit more interesting by creating this small extruded part. I'm going to bevel on that one. Always looks better, something like this. Okay, so I like this part. I'm just going to copy it over to the other side. And since it has the same angle as the front, I can just take this part, rotate it slightly, and we can use it for the same type of connection. There we are, 180-degree rotation, and just move it in the right spot. So another small thing we're missing here is a little bit more armor on the pistons that move the front blade up and down. Just using a plane here. Well, a plane or a box, it's all the same. Just creating this sort of armored part around it. Looks okay. this sits mostly at the back, since there are a few sides to it. This armored part, you're still supposed to be able to take it apart, so it's not completely solid. I mean, they still have to be able to perform maintenance on this bulldozer. So that's why they think about these things and make sure you can take them apart while not compromising on security. So that's what this part looks like. Forming a shell just to get thickness in there. And just remember this one, if you want to create these armored plating parts around something, then just use shell, it's easy. Move that one over there. Select those edges and then move them slightly down. And this one's a little bit thicker than the other one, so I'm adjusting that as well. And it sort of slopes down at the bottom. And there we are, that looks almost okay with the shell added. I've chamfered the front part there to make things a little bit harder because I had a little bit of slanting at the bottom. And with the general shape of that part done, I'm just going to continue and add a little bit more of those small details. As you can see, I've used the cylinder here together with a slightly modified model of the nut that I use all over the model. Just duplicating this around a little bit, something I've been doing all along. Side extrude to make it a little bit more interesting, together with a bevel. You've seen this being done a few times before already. So that looks okay. I'm going to copy it down there 3 times, it looks about right, and then take it 3 times to the other side. As you can see, this is what makes the 2 armor parts stay together. They're just a few cylinders with nuts on them, and that way the 2 parts are bolted onto each other. Okay, with that done, as you can see here, I'm drawing some splines, and these splines will form the hydraulic hoses that I was talking about. And right now I'm just taking the Bezier handles and moving them around slightly. So at the back here of the that big piston, I made a few very simple parts. They're just cylinders with a few extrudes and insets on them. And these are the actual sort of, how would I call them? The valves or the connections for the hydraulic hoses. This is where the hydraulic hoses feed into the pneumatic systems. And so there's actually like a pneumatic hose running along that tag link beam. And I've drawn 2 here. They go in at one side and then come out at the other side. And interestingly, these hydraulic parts, they originate from somewhere around the front of the hood of the bulldozer. So that's where I'm actually creating them. Made a little bit longer using the create line. And then just moving this part around slightly. As you can see, it's a little bit hard when you draw parts in 3D to make sure that they all line up correctly. Need to modify the Bezier handle a little bit here. So that green one looks okay. I'm going to change the color. And now I still have that blue one to do. And it's just the same thing. I move them around a little bit and make sure that the flow of the hoses looks natural and not with some unrealistic bends and the like. There's really quite a few of those hoses that come out of one side. I think there's about 4 or something. So here's the 3rd one. I'm just copying one and then slightly modifying it, as that's much easier than creating a new one from scratch. And the 4th one here, I start with moving it around a little bit, and then I take the separate Bezier handles and move them around until it looks similar enough. So there we are. Here you can see me creating what is the attachment for these pneumatic hoses. It's just a cylinder, very simple. Then I perform a bevel, an extrude, an inset, and then just add a few edges to make sure that the model smooths correctly. Okay, so moving these slightly so that they will connect nicely with the attachments for the pneumatic hoses. Move this one down, move that up, and there we are. Now they should be all attached. Okay, so we've got it done.